So I gave you this mathy question and asked you to determine what is the delta x of this spring over here at the end. So just to revisit, we have a block with a mass of 7 kilograms. Let's just call it a ball. It's clearly not a block. It swings down on a pendulum, um, creating a perfectly elastic collision with another mass. Uh, Notice that the final velocity of the ball here is 0. So it transfers all of its energy, because it has no energy at the end, or it has no kinetic energy at the end. Transfers all of its energy into this block, which runs up a frictionless surface, goes up a height of 1.2 meters, and then runs into a spring. Okay. So if we just start from the beginning, we know that since this ball is 3 meters off the ground, and because it has a velocity of 0 meters per second, it has u, and u can be calculated with mgh. It does not have kinetic energy, right? Because its velocity is 0. Now, I'm going to do this very mathematically. Like value-based. I'm not going to use the variables because it makes it quite a bit easier. This isn't necessarily the way you would do it on a AP exam, but here it is. The mass was 7, gravity I'm using 10, and the height was 3. So right off the bat, we know that there are 210 joules of energy. Okay. Now, I just want to point out to you that this ball, when it gets down here, like it starts out with U and no K, and then the U goes down and we get a little bit of K, and then the U goes down and we get a little bit more K, and down at the bottom we have no U and all K. And since the final velocity after the collision of this ball is 0, that K all gets turned into here. But please recognize that we started out with 210 joules. So collectively, we're going to have 210 joules there, 210 joules there, 210 joules there, 210 joules there. When the block gets up here, it's going to be traveling with a velocity. It will have k, but it will also have a little bit of u because it's up in the air. And that collectively is 210 joules. And when it compresses the spring, it will have spring potential and gravitational potential, but it won't have any kinetic energy because it'll be stopped. So we know that at the end here, U of the spring plus U from gravity needs to be 210 joules. Now, you may have collectively found some values here, but you didn't need to. The big point was that there's no work being done anywhere in this situation. So all of the energy is conserved. So it's spring potential. Hey, leave me alone. Spring potential says that we have 1/2 kx squared. Again, that x is what we're looking for. Plus mgh equals 210. Well, we've got 1/2 of 0.4 x squared plus, this is a 5 kilogram mass, 10 for g, 1.2 for the height at that point, gives us 210. A lot of you guys, when I looked at it, you said that, look, it's got 60 joules of energy from gravitational potential at this point, but we didn't really calculate for the other 150. So I'm just going to move this a little bit, and we should have 150 joules left that make up the 1/2 of 0.4 x squared. X squared ends up being 750 joules. So the total displacement ends up being, it was about 27-ish meters. I don't remember what the actual calculation is.